R. So this V squared is going to give us what? V squared is going to give us, let's put it here. V squared is going to give us V squared is equal to Ix L minus Ix C squared plus I squared R. So x comes out, x comes out, xl minus x c all this squared, okay, plus I squared R equal to V squared. Now this will become what? S will become S squared out, okay, it will come out as x squared and I squared x subscript L minus x subscript C plus I squared R. This is the same, so that comes out. So V squared is equal to this into bracket x L x C minus R, plus R. So what will happen? We find square root of that. Square root of this will give us V. Square root of this will give us I, and then we have square root of xl xc plus I. Sorry, they are squared, okay, squared, they are squared, okay, so let's put a square there. Squared, here. Right, so that I will be equal to what? V over square root of what? xl xc squared plus R squared. This is the expression we are interested in. Okay? This is what we are interested in. With this gives us an expression for I. And that is very crucial. So from here you see that the effective overall resistance, what we call impedance, it will be over Z, which is the impedance, overall resistance. So this V, this Z is equal to what? The square root of what? XL, minus XC squared plus what? R squared. Right, so this is what, once you get this, you are through. Now, if we have been able to do this for in series, in parallel, it's just a small manipulation and then you get it. So that is how you do it. So that's the formula, how to divide the formula. So you can do a lot. Once you know which is leading, which is leading, but then you can do the calculation. So let's say if we were to do that for let's say in parallel connection. Okay, so in parallel connection, all you need to know is here, in this case, voltage is the same. The current is varying. Okay, right. So you need to draw your chart. Okay, let's say the chart is you have your phasor, the phasor diagram. Okay, so for let's say for capacitor, we know the current needs the voltage. Okay, right, but here voltage is common. Voltage is common to all of them, so voltage is here. Right, it's common to all of them, so it means R, L, and then our C, they are all the same. Okay, because it's in parallel connection, is the current which is changing. So in that case, let's see where the current for capacitor, current leads voltage. So current, so I, capacitor over here. Then for inductor, voltage leads current. Okay, so it means this voltage, so because it's leading current, inductor, current over here. Okay, if there's a resistance, let's say there's a resistance, then the resistor, as for it, it's always in phase with the current. It's always in phase with that. So that will be your resistance here. Right. Now, if we want to find the effective resistance, if we want to find the effective resistance, is the difference between the two, to get I C minus I L. Okay. Then find the this and the second one. Okay. So we just come back to the same thing like we did. But this time we are looking at what we are looking at the difference here. So this is the effective current. Okay. So the effective current squared will be equal to your I minus IC minus IL squared plus what? Plus what? So we are looking. So this will be the current in the resistor. Okay. Squared. Okay. So this is how it's going to be. And then from here you can work things down. You can work things down in the sense that you know I V is equal to IR. Okay. So it becomes what I is equal to V over R. Okay, so you put that expression. So in this case, this becomes what V, which is the same over your R, which is inductance, which is the reactance. The resistance of an inductor or capacitor is called reactance. Okay, because it's not in one direction, so you won't say resistance. Okay, so it's what do you call it, the reactance, okay, for that. Okay, so in that case, the reactance for C minus reactance, the same thing for L all squared plus V over R all squared. Okay, so you see that you can go on and on. So what will happen is this is common, so it will come out as V, and then you have inverse of that. So at the end, first when it comes out, it's going to be squared. Then you have this one, so squared, V squared over. Okay, then you can factorize the V squared out so that you have 1 over this. So this is squared, okay, and this is squared. Right. Then you have so the square root of this comes out as 9, and this comes out as V, and this is the square root of all this. Okay? Right. So when you have this, you have your V here, and what I, V is equal to I over R, okay? Right, so resistance becomes what V over R. This expression for resistance becomes V over R. So you can make it, you can let this one come, let this one go here, and then this is inverse, okay? So this comes out. So we want an expression for V. We want to make V this, so let's, from here, what we want is we want an expression like this: R is equal to V over R. Okay. So what you can do is, if you let this come here, and then this go there, it will be the same. Or in other words, what you can do is, since we are interested in V over R, we let this come here, and this multiply, so it come and divide. So it will be 1 over this whole thing, this expression that we have here. Is equal to V over I. So it's equal to Z, the impedance. So the impedance will be the square root of this. Okay, 1 over the square root of all this expression. Right, that is 1 over Z L minus 1 over Z C. So this C is L all squared plus 1 over R squared. Okay, that will be the impedance, the overall resistance to flow. Okay, so these are the ways that you can, the methods that you can use to calculate the various formulas. Okay, so this is for parallel. We have done that for the series. And 3, putting all the 3 together. It means if you are dealing with 2, it should be easy for you. Right. The last bit I want to add is when we did the calculation for V and said we need instantaneous V max sine 2 pi Lt. Okay, and then we said the Q is equal to CV. Q instant is equal to this instant, and then we came to the point that Q instantaneous Q is equal to C into bracket V and sine 2 alpha t. Okay, why we said this, the Q dt is equal to current, so we want to find an expression for current. So in that case, we can say differentiate this side with respect to t, differentiate this whole thing, also differentiate this whole thing also with respect to t. So that what you do to this side, do the same to that side. So that this becomes what? Current. This becomes instantaneous current. Okay, so that is V, variable V, okay, instantaneous current that we are looking at. Okay, so in that sense, this is going to be the constant out C out. V is also going to come out, Vm out. Alright, and then we have differentiation of what? Sine 2 pi Ft over dt. Now this comes out as I instantaneous becomes what? C V max. Now if you are if you are differentiating sine, the coefficient of what you are differentiating with respect to comes out. Okay, so 2 pi f. Then we have what? Sine 2 pi. Repeat that again. Repeat that one. And this is it. Okay, so this gives you I instantaneous is equal to C V max. Let me write it well. It becomes what? 2 pi f C V max. So when we differentiate sine, it becomes what? Positive cos 2 pi ft. Right, look at this equation very well. Okay, this has given us a cosine curve. Okay, so this whole thing is constant, and this is the instantaneous distance. So you can see that at this point, if this is an instantaneous, let's look at the formula here. When this is instantaneous, this is the V max. So if this is the I instantaneous and this is the equation, then this becomes what? I max. Okay, I instantaneous I max cos 2 pi ft. So it means I max is equal to 2 pi f c V max. So if you want to find the maximum current for the alternating current, this will be the formula that will be flowing through the capacitor. So this is for the capacitor, that will be for the capacitor. This part is what I wanted to draw our attention to. So the basis is we know from first principles how to get which one is leading, which one is lagging. And once we know which one is leading, which one is lagging, then we move on to parallel and then series connection. In parallel connection, we know the voltage is the same, current is varying. In series connection, we know voltage is different and current is the same. So once you get the same thing, when it comes to the phasor diagram, the same thing comes here, then the variables, you put them here. You find the resultants. The resultant, because they are factors, you can't just, because they are vectors, you can't just add them. You must consider the angles, and that you can use the Pythagoras theorem to arrive at the answer. When you get the expression, find the expression for impedance, which is the overall resistance for the 3 or 2 components that they need. Thank you.